Hello, my name is Philippe Van Kerm. I'm a professor of social inequality and social policy at the University of Luxembourg and the Luxembourg Institute of Socioeconomic Research. In this video tutorial, I want to remind you to check the sensitivity of your results to your choice of equivalence scale. Well, if you don't know what an equivalence scale is, just follow this video very carefully. And, well, if you know what an equivalence scale is, I think this is still a healthy reminder. Inequality and poverty analysis uses total household income as a measure of living standard for household members. And it's assumed that everyone in the household has the same living standard. Everyone achieves the same living standard, and that's a function of total household income. One problem here is the comparison of household incomes when the composition of households differ. Consider a person living alone with 2,000 euros. Consider now a family of 4 living with 4,000 euros. So, which of the two has the highest living standard? Well, family of 4, they have 4,000 euros. But are they twice as well off as the person alone with 2,000? Well, clearly they need to feed more mouths. They need to find larger shelter, and they need to entertain more people, etc. There's definitely more expenditure. No. Alternatively, we could think on a per capita basis. So, divide total household income by the number of people. Well, now, clearly, the first person would now be twice as well off as the family of 4. Well, problem is, the family, well, they live together in one household, they can take advantage of economies of scale, they don't need 4 times larger accommodation, utility rooms and furniture, all of that can be shared. Buying in larger quantities can be cheaper, clothes and toys can be passed on across siblings, and children tend to have lower levels of expenditure than adults. So, the amount of expenditure, the needs, if you like, of the family of 4 is likely to be less than the corresponding per capita value. So, on balance, it's not at all clear which of the two households should be said to have the higher standard of living. And that's where the equivalence scales are used for. So, they're used to allow comparisons of living standards on the basis of household income and household composition, when household composition can vary. Practically, they are conversion factors that transform the income of a household of composition, say H, into an equivalent income for a reference composition, typically a person living alone. So, for example, here, application of a fairly common equivalence scale to our example, so the square root scale, might lead us to say that the family of 4, in fact, has a single adult equivalent income of 2,000. And in that case, the two households actually have the same living standard. Formally, we can represent the equivalence scale as follows. So consider household of income Y and composition H. Okay, that's a particular given household. Total income Y, household composition H. And here we try to find the level of income Y tilde up that would bring the same living standard to that household if it had another composition, a reference composition, for example, an adult living alone. So if we say that the living standard is a function U of income and composition, well, we can write this problem of finding the equivalent income as simply solving this equation. Usually we'd assume that U of Y of composition 1 is simply equal to the total household income if living alone, but that still leaves a lot of freedom in how we define this function. Okay, and that's, if you like, the formal expression for equivalence. Now, concretely, equivalence scales are rarely expressed by specifying this function U directly. One could think of very many alternative definitions of equivalence scales, but in fact, very few are used in practical applications. And here is the set that you'd find in a vast majority of applications. All these scales have the same simple form. Equivalent income is obtained by dividing total household income, here, by a notional number of consumption units in the denominator. And a consumption unit is one that is thought to consume as much as a person living alone, taking into account these economies of scale of living with other people. And in fact, all these different equivalence scales only differ in how the consumption units are counted. So in these expressions, so AD would be the number of adults in the household, and CH, as you've guessed, is the number of children. And number of children, well, we can discuss how these are defined, but they're usually taken as people aged 16 or less, or 18 or less, or sometimes 14 or less. Okay, let's look at the first equivalence scale, the square root scale, sometimes called the LISSY scale. So it takes the square root of the total household size as the number of consumption units. And equivalent income is therefore obtained by dividing total income by the square root of total household size. So a family of 4 has 2 consumption units, and according to these scales, if we apply that to our earlier example, this would give a family of 4 with 4,000 euros a living standard of 2,000 euros, which means that the two situations in our first example were actually reaching the same living standard. So that scale is the scale that's used to calculate the LISSY figures, if you look on it. And what's specific to that scale is that each additional member makes a smaller and smaller contribution to the number of consumption units. Well, that scale here is in fact a special case of this more general parametric, if you like, expression for an equivalence scale, where the parameter is theta, which is a number that can vary between 0 and 1. So if theta is 0.5, we've got the square root scale. If theta is equal to 1, well, we ignore all economies of scale. We just divide total household income by household size. That's the per capita definition. And if at the other extreme we set theta to 0, we assume that, well, there's perfect economies of scale. So everyone in the household receives the total household income. And these are the bounds to this expression for the equivalence scales. Well, another form of equivalence scale is the so-called Oxford scale, or sometimes called the OECD scale. And here, the number of consumption units is defined slightly differently. So here we're assuming that the first adult in the household always counts for 1. And now we are adding a smaller number of consumption units for each extra adult and each child. So here, every extra adult would count for 70% of the first one, and each children count for half of the initial adult. Well, that scale is in fact now fairly rarely used, and people tend to use the so-called modified OECD scale, which in fact just redefines the weight of the extra adults and the weight of children to 0.5 and 0.3. So this assumes that there are larger economies of scale than in the Oxford scale. Okay, there's more economies of scale in household consumption. And in fact, that particular scale is the one that's being applied by Eurostat, and that's being applied in all calculations of European social statistics. Of course, again, one can combine expressions and derive fancier expressions for equivalence scale. So if we combine the two approaches, we could use an equivalence scale like this, which now has 3 parameters: the weight for additional adults, the weight for additional children, and we can combine that with a power function given by gamma here that is in fact a combination of the square root scale and the Oxford scale or modified Oxford scale. Clearly, those are not the only equivalence scales possible. So, for example, in the UK, it's an equivalence scale that's being used very often in official statistics is the so-called McClellan scale. And this one differentiates more age groups, uses another reference. The reference household is a 2 adults household, and use different implicit weights for additional adults and children. Now the question is, does the choice matter? And, well, the answer is, well, quite possibly. So let's look at this example, just to fix IDs. And so we have now 4 different family types. A person living alone on 800 euros, 2 people living together on 1200 euros, 2 adults and a child living on 1500 euros, and 2 adults and 2 children living on 1800 euros. Okay, so who's better off, who's worse off according to the different equivalence scales? So, of course, if we think in terms of total income, well, yes, the richest household is the bigger family, and the poorest household is the single person. Okay, but more mouths to feed here, and more economies of scale. So what happens if we make adjustments to that? Well, on a per capita basis, the person alone is best off, and the family of 4 is worst off. Square root scale? What happens with the square root scale? Well, the square root scale now considers that with a family of 4 and 1800 euros, so recall you divide 1800 by the square root of 4, that's 2. So divide 1800 by 2, we've got 900. So 900 is the equivalent income received by every member of that family of 4. And that's the largest of all 4 situations. The worst off in this situation is now the person living alone. So here the effect of economies of scale is quite large. Had we applied the Oxford scale, well, we would have an entirely different ranking. Now in the Oxford scale, the person living alone would be the best off, and the family of 4 would be the worst off. We would also have a change in the ranking of the 2 middle cases. EU social statistics, for example, now use the modified OECD scale. What happens with the modified OECD scale? Well, we have a ranking that's similar to the square root scale. Now, the best off is again the family of 4. The first 2 cases, the adult alone and the 2 adults with 400 euros more, have an equal living standard, and the family of 3 is in between the 2. So we've got a ranking that's consistent with the square root scale, but even though the ranking is consistent, the relative differences are quite different. So here, the relative difference between the first and the last is actually much larger in the square root scale than it is in the modified OECD scale. Does it make a difference? Yes. So even those fairly standard choices can make quite a significant difference to the ranking and the relative positions of those families here, with not so much difference in the household incomes. Now, is this likely to make a difference to your research? Well, it's been found that this is potentially relevant to research that's trying to compare the situations, the relative situations of different population subgroups. So if you're looking at the situation poverty among children or poverty among the elderly, and how their relative position with respect to the total position, well, the choice of an equivalence scale is likely to make a difference. Now, apparently, if you look at general trends and cross-country patterns, it usually reveals a lot less sensitive to the choice of an equivalence scale. So, depending on your research, you may want to reflect carefully about the choice of an equivalence scale and assess the sensitivity of your conclusions to alternative choices. The application of equivalence scales for wealth or net worth comparisons. So while it's easy to agree with the relevance of equivalence scales in comparisons of income, though we may disagree on the specific scale, the question is a lot more thorny when we want to compare wealth across households of different characteristics, wealth or net worth. And, well, we can view the stock of wealth as a measure of future consumption capacity of a household, in which case one would argue that, yes, equivalence scale should be applied, but wealth is not exactly income. So first, wealth is not consumed immediately. So if it's an indicator of future private consumption, it's future household composition which should matter. Should we discard young children from a household? But how to take into account bequests? This is all very unclear. I think this is a very complicated question. Now the second point is that for many households, real assets is the largest share of their net worth or their wealth. And in this case, there's a lot of economies of scale in consumption. If we think of the service value of housing, for example, but there's a lot of economies of scale, probably much stronger than in income. But third, wealth may not only be relevant for consumption, but instead is considered important because it measures power or prestige, family prestige, or household prestige. In this case, it's unclear whether one should divide family wealth by the number of family members, or if everyone benefits from the total wealth in the same way. In which case, there's perfect economies of scale in terms of prestige or power. Finally, some research examines wealth as a measure of a national stock of capital. But in this case, if we are applying equivalence scales and think of economies of scale, then we would be artificially inflating the aggregate stock of capital. So if we want to measure net worth as the physical stock of capital, well then no economies of scale should be considered. So clearly the choice here depends on context, and the practice is usually to ignore economies of scale and to consider the distribution of wealth across households. But I think more research should be done here to actually clarify concepts and practice. So let's now look at a simple example using LISS and see how much results can be sensitive to the choice of equivalence scales. Let's give this a try. So, uploaded the LISS web interface. Let's select LISS and Stella scales. And I have prepared a do file which we can download from the LISS Data Center website as it goes along with this video. So let's upload this. This could move up. So LISSY is ready to start it. So let's look through this example. We're going to use the US 2018 household level file, very few variables, household identifier, that's disposable household income, 3 indicators of household size, the number of individuals aged 17 and below, individuals aged 13 and below, and that's the total household size. And we're also obviously going to work with the sampling weight. For the sake of illustration, I will want to compare poverty rates according to the age of the household head. So we need to pick up the age of the household head and pick it from the P file and bring it into the H file. So it's M to 1 merge from the H to the P, and here I'm only using H and the relationship variable. Okay, this is a merge on HID, and we only keep observations in the P file for which relation is equal to 1000, which means the person is the household head. Now we can create our equivalent income variables. So we will experiment with 5 different choices here. The first one is the per capita. So we simply divide total household income by the household size. The square root or least scale, dividing household income by the square root of household size. We are also going to consider the other extreme equivalence scale by considering that there's perfect equivalence economies of scale, so everyone in the household benefits from the full household size, so the total household income is not divided by anything. And then we consider the Oxford scale and the modified OECD scale. So here we divide total household income by 1 plus the total number of people in the household minus the children. Here we're going to take children defined as people of age 17 and below, minus 1 times the weight of 0.7 plus the number of children with a weight of 0.5, that's the Oxford scale, and the OECD scale is defined exactly in the same way, except that we are changing the 2 values here, the weight of adults and the weight of children. Oh, there's no more to do than this to define those equivalent incomes. I'm going to define 4 different age groups, so households in which the head is age less than 30. Second group is households where the household head is aged between 30 and 44, then between 45 and 59, and then from 60 anywhere up to 120, which I expect to cover the overall sample. That's an important line. So we are going to look at the distribution of individuals. So we're looking at poverty in the population of individuals, not the population of households. So to do that, from the household file, well, we need to multiply the household level sampling weight by the size of the household. So each household counts for the number of people in the household, independently of the choice of the equivalence. That's a different parameter. And then I'm also going to calculate the rate of poverty among children. And to calculate the rate of poverty among children, now we are going to focus on the population of children. So in this case, the household weight is multiplied by the number of children in that household. And of course, all households that do not include any children will have a weight of 0, will actually effectively be discarded from the estimation. As usual, we can SVY set the data. This is only going to be used to calculate the child poverty rate, so we are using this variable PHWGT17 as weight variable. This can be a little more complicated if we, in the same script, we are combining estimation across different populations, because this SVY set needs to be adjusted every time. And then that's it. For the rest, we are just now going to repeat the same 3 commands, but applied to different income definitions, or equivalent income definitions. So what do we do here? So let's say Y is income per capita, and this line here is simply first calculating the poverty line. And I'm using the European definition of the poverty line as 60% of the median of equivalized household income in the population. So to do that, I'm using this poverty command for simplicity. Now the second line is using Stephen Jenkins' PovDeco command to calculate the poverty rate by age group. So we're going to calculate poverty statistics disaggregated by age groups using the poverty line which is calculated by the previous command. And then finally, I'm using poverty again, but now to calculate the poverty rate among children. So I'm considering the population of children, and we are calculating, well, just focusing on poverty rate, so looking at a fraction of children who live in a household whose income is below the poverty line. So I'm using this SVY prefix here because I want to check the standard errors and confidence intervals, and I restrict it to the population of households that are actually a weight positive. So for households in which there's someone aged 17 or below. This is it. So we will repeat that for different definitions of equivalence scale, and we're going to check whether this makes any difference to the results. So let's start that. So what do we get? Well, we have here 11% of households that are headed by a person aged less than 30, 28% headed by someone aged 30 to 44, 27% headed by people aged 45 to 59, and 33% of the sample that's headed by someone aged 60 or above. And let's focus on those 2 extreme age groups. Okay, that's the SVY set declaration. So let's first look at the profile that we get if we focus on income per capita. So we divide total household income by the number of people in the households. We have a poverty line of $13,685, and that in the overall population would give us a poverty rate of just under 25%. Notice here we are keeping in the estimation observations that have an income equal or less than 0. This can be other discussions whether we need to do that or not. But here, let's keep them for all calculations. Now, let's examine the profile by age group. So this is the output of both DECOM. I think the most relevant statistics are here. So these are the poverty rates for each of the 4 subgroups. And we see that poverty rate among younger households is really high, 35%. And it declines, the poverty rate declines with the age of the household head. So it's down to 19% for the elderly household and very similar amount for household headed by someone aged 45 to 59, just under 20%. So if we examine the relative differences, so that's the ratio of poverty in that age group divided by the overall poverty in the population. So we see that the poverty rate among young people is 41% higher than the poverty rate in the population. And for the elderly, it's 23% lower. Now let's look at the poverty rate among children again. So we focus now on the number of everyone in the sample age 17 or below, and we calculate which fraction of those children live in a household that has an income below the poverty line. And that's almost 40%. According to that scale, almost 40% of children live in a household that's considered poor according to that definition of being below 50% of median income. Do these results hold if we use an alternative definition of the equivalence scale? Of course, the one we've looked at using per capita is one of the extreme cases. Now let's consider the LISSY equivalence scale. What happens? Well, on the whole, we still have 24% as poverty rate in the overall population. So that's hardly different from what we get in the per capita calculations. But now, the profile by age is getting very, very different. I think it's probably easier to remember that number. So now, the poverty rate among young people is 35% higher than in the overall population. But now, if you look at the elderly, well, the elderly are also overrepresented in poverty than the overall population. So their poverty rate was 27% below the national poverty rate, according to the per capita definition. But now, applying an equivalence scale, the square root equivalence scale, we observe that the poverty rate is actually higher. Now, if we look at the child poverty rate, we see the child poverty rate is now 29%, down from 39%. So once we apply economies of scale, the rate of poverty among children declines dramatically. And of course, that's to be expected. Children usually don't live alone, so they live in larger households. And of course, once we allow for economies of scale, we are then increasing their living standards than if we just divide total household income by the size of the house. And if we take a per capita reference. Now, if we go to the other extreme and consider that everyone in the household takes advantage of the full household income, so we now see that poverty line is much larger. So we're actually creating a lot of income, if you like, equivalent income in the population by allowing for more economies of scale. Again, the poverty rate, the aggregate poverty rate, does not vary all that much. It was 24%, it's now 26%. But if we look at the profile of the age profile of poverty, well, we now see that the elderly are those where the relative poverty is much larger. And as it goes, well, we still have a decline in the poverty rate, in the child poverty rate, by having those larger assumptions about economies of scale. Again, that's not unexpected. And I will let you look for yourself, run this script and look for yourself what happens with alternative economies of scale. You see the Oxford scale also remains very similar to the per capita. Whereas if we use the adjusted or modified OECD scale, which is, as I said, the standard in European statistics. Now we have a profile where young people are still higher levels of poverty, but now the elderly also are above average. So this is it. Discussion of implications of equivalent scales. I think they're all too often forgotten, but these can be an important analysis decision, so I can only recommend to check the sensitivity of your main conclusions to your choice of equivalent scale.